Hi and welcome back. In this short video I want to make you aware of a typical challenge when dealing with token-based systems and how we typically approach that problem. And the problem or the challenge is access token management, or OAuth access token management. So ultimately, when you're building a system that is using an OAuth authorization server, your client application will get an access token, right, and use that to call APIs. So far so good. Now this access token will have a finite lifetime, meaning it will expire after a minute, after an hour, after a day, whatever that value is. At some point the access token will expire and your client application needs to get a new one to be able to continue calling the APIs. Now there are two fundamental, I guess, different environments where you need to manage access tokens, and one is worker applications, or some call it daemons, or machine-to-machine style applications where two machines are talking to each other. There is no human involved there. There was no interactive log-on workflow involved, for example, which makes things a little bit easier. And then, of course, the opposite of that, which is interactive applications, like, for example, web applications or anything where a human being, so to speak, is involved, which means we have to open a browser, show a login page, get tokens, and then manage the tokens while the user is working inside the session. Okay? This is a problem that every single application will have if it is using access tokens, and there is nothing built into .NET or ASP.NET to help you with that challenge. So we built a library exactly for that purpose, because basically, as I said, every single customer we have has that issue, yeah, and that library lives on our GitHub organization. When you scroll down, there's a section called free open source. It's called automatic access token management for worker and web applications, or short duende.access token management. And you can get all the code here. It is an Apache 2-based license, so you can use it and modify it and put it into your own products or projects if you like. And basically all I want to do is quickly walk you through what this library can do, and everything I'm saying basically I have also written down on the wiki. So you see basically we have the three big scenarios that this library targets, which is worker applications, web applications, and a variation of a web application is a Blazor server application, because the rules are a little bit different here. Okay, so let's start with the worker applications and what the challenges are here. So basically a worker application, the way this works is it's typically a machine-to-machine style communication, right? So like some background service or some batch processing, or just the server part of a web application talking to some other API, not in the context of a logged on user, basically two machines talking to each other. And in OAuth speak, this is called the client credential flow, meaning your client has some sort of credentials, it talks to the authorization server, gets the token, that's step number one. Then the client will use that token to call APIs, and for performance reasons and efficiency purposes, you should cache that token. And then once the token is expired, you basically start over, get a new token, and continue calling your APIs. That's the typical pattern for machine-to-machine style communication. Okay, so let's have a look at the code base here. So basically, when you clone the duende.access token management code base, that's the repo. It has all the code in there, and there are a couple of samples in there, and I will walk you through one of the samples to show you basically how it works. So we're going to start with a sample called worker, which is exactly what it is. It's a machine-to-machine style communication. So it's using the .NET worker, whatever they call it, thing. And as you can see, basically we are creating a host here, and then we are configuring a couple of services. So the first thing we added to this which was pretty much the standard template, is a NuGet reference to the Duende.access token management. Now, I said that the typical pattern would be to request the token, cache the token, use the token, and then once the token has expired, get a new token, cache that again. So by default, we are using here the distributed memory cache of .NET to cache the token, which means you can plug in various other implementations like Redis and I guess SQL Server and so on, or you can replace the cache altogether. But some sort of caching implementation is required to make this library work. And then we are adding the client credentials token management services to the DI container. And the idea is pretty simple. You're just registering token clients, right? So basically a token client is basically a configuration how to talk to an authorization server. You give that token client a name, demo in this case, and then you configure, okay, so whenever this client needs a token, where's the token endpoint? That's where we configure the token endpoint. What's the client ID and what's the client secret? Okay, and you can use various client credential types, like as I said, shared secrets in this case, or JSON Web Tokens, or X509 certificates, and so on. This is all extensible. And I should mention, we are using a demo instance of Duende Identity Server to make this all work. That's living on this URL here, and you basically can see that there are lots of demo clients pre-registered for you. So you get the client ID, you get the client secret, you see the access token lifetime, how long this token will be valid, and which APIs they can call or scopes they can request, right? So going back here, you see that we are using a client called M2M for machine-to-machine.short. And what that means is this is a client ID where the token lifetime is 75 seconds, and the reason why we are doing that is to be easy to demo the expiration of tokens and the rollover and requesting a new token and so on. But normally, typically, I guess your access tokens would have a longer lifetime than just 75 seconds, and if you want to do that, you can just remove the short here and get something which is something with 60 minutes, for example. Okay. So anyways, so back to our configuration here. So we are registering a client here called demo, and that's the configuration details, and that's the scope we're gonna request whenever we're gonna request a token for this client. And you see that you can have more than one client registered. So if you have multiple token configurations that you need to support in your single host, then you can register as many of those and attach as many of these client-specific configurations. So that one, if you are curious and want to have a look at the source code, this is not using shared secrets here, this is using a JWT for client authentication. Okay, cool. So now, once we have that set up in DI, there are multiple ways now to use that. And the easiest one, let's go to the service called worker manual. You see here that's our worker service. And we are getting taking a dependency on a service called iClient Credentials Token Management Service. So that's a service coming from our library, and that has exactly one purpose: to give you a token for a given client credentials token client. Okay, so you can see basically whenever the service is running, it creates a plain HTTP client from the HTTP client factory, configures that HTTP client, and then uses the token management service and says, hey, give me an access token for a client called demo. Okay, and that is basically this client here that we configured in DI. Okay, so this will return a token. Then we set the token on our HTTP client, and then we use it to call the API. So the way this service works is it will always return you a token, and if this token is null, that means, we tried to get a token, we tried our best, use the cached one, try to get a new one, but for whatever reason it didn't work out. So there is no token we can give you. There's a problem. Okay, this should normally not happen, but basically what this get access token async does is it looks up the cache. Do I have a cached current token. If yes, return that. Otherwise, try to get a new token. And if that succeeded, return that. And if all of that would fail, it would return null, which ultimately would mean your response would be a 401. Okay? Good. So anyways, so that's that. Basically, you get a token, you set the token, you call the API, everything is good. So let's actually, let's see which one we have here. So let's run the worker manual. Okay, and then there is some logging going on, debug logging, so you can basically see what's going on here. So you see the very first call we're doing, we're getting a cache miss. We don't have a token yet for the client called demo, which means we're getting a token from this endpoint here, and then we are calling ultimately our API. Okay, so if you scroll down, you see next time we're getting a cache hit because we already have an access token which is still valid for this client called demo. We're making the API call and so on. And then, you know, after a certain amount of time, we will see a cache miss again because our token has expired. There's also a configurable buffer. So basically what the library does by default is tokens which are valid for less than 60 seconds are considered to be, you know, expired, and we're getting a new one. That's why 75 seconds means basically roughly every 15 seconds this client application is getting a new token. And you can configure this buffer, but you know, it's basically good to be a little bit proactive here. Okay, anyway, so this is now running forever, and you'll see that basically every I don't know, 5 seconds it makes an API call, and every 15 seconds it gets a new token, right? And that's the whole idea of this sample. Okay, you can so that's what we call using our APIs manually. There's another abstraction layer that you can use, and that is basically by using the HTTP client factory. So in other words, what you can do as well is, instead of using the token management service directly, you can register HTTP clients with the HTTP client factory and couple that internally with the token management. So what that means is basically what you can do here is, you see, I'm registering a client here. The client is called client, okay? And it is connected to the token client definition of demo, which is the thing we have above here, okay? So, and then you can, as normal, configure this HTTP client in any shape or form you like. But what that basically means is, whenever the application code uses an HTTP client called client, it will, under the covers, you know, do the whole thing, like looking at the cache. If the cache is missing or the token has expired, get a new token and so on. So in other words, the outcome of that is that your business logic should have no code whatsoever dealing with token management. Okay, so if we look at this worker HTTP client, and that's exactly what's happening here. Instead of having a dependency on our management service, we have a dependency on that HTTP client factory, and whenever the business logic needs to make an API call, it just gets the client from the factory. And remember, this client is internally connected to the token client definition, and it just calls the API, and then there's no token handling whatsoever. Okay, and you know, again, you can even abstract that one step further if you want that by using a typed HTTP client. And basically you can see here, I'm basically just adding a typed HTTP client, again doing all my things, and then just connecting that to a token handler that, again, under the covers takes care of the token management. And as you can see, if we go to the typed client, this just gets the client injected, and then it calls APIs, no token handling code whatsoever. And if we look at the worker that is using that typed client, again, same thing, right? It gets the client from DI, and whenever it needs to call the API, it just calls the client. Okay, so just to prove that this is working, let's run the HTTP client version of that, right? And you'll see it has exactly the same outcome. It will, the very first time it's going to be a cache miss. We're getting the token, calling the API. The next time it's a cache hit, okay? So we call the API, cache hit again, call the API, and I think the next time, yes, it's a cache miss again, and we are getting a new token and calling the API. Okay, so that's it for the worker. Now, for web applications, the whole story is a little bit different, right? Web apps basically have interactive users, meaning a user opens the browser, for example, you know, like presses the login button, the whole login workflow happens, right? And then typically what we get back is an access token to call APIs and a refresh token, which is the thing that we can use later on to get new access tokens without having to do the UI workflow again, right? And that is typically what in OAuth speak is called the authorization code flow, yeah? For the protocol geeks, with Pixie, which is a little addition which is very important, and it's turned on in ASP.NET Core by default. But ultimately, as I said, this will result in 2 tokens. Well, actually in 3 tokens, but you know, like we're gonna ignore the OpenID Connect side of the world for now. But basically it will give you back an access token, just like we've seen in the worker example, and a refresh token. And the purpose of the refresh token, as I said, is that you can programmatically get new access tokens without having to involve the user and an interactive workflow again, right? So the typical token management steps here are very simple to what we just, very similar to what we've just seen with the worker applications. But this time, when we request the token, right, we cache and use the token, but we also cache the refresh token. And when the access token has expired, you know, use refresh token to get a new one. And then the whole thing basically starts over. So we go back to step 2. Okay. The initial token request is typically what you want to avoid, but because, as I said, this involves browser interactions. Okay. Cool. So again, this flow is implemented in this library, and again, all of the things I'm going to show you are in much more detail in the wiki that I showed you on our page. And also I should mention that the access token management library is split up in 2 NuGet packages. One is just the plain access token management we've just seen for worker applications, and one is specifically for ASP.NET Core applications using the OpenID Connect authentication handler. So there's no need, if you're just doing a, you know, like a background worker, to pull in all of the ASP.NET Core dependencies. But if you are in ASP.NET Core, then you probably, you know, you want to use all of this, and then you basically pull in this package, which then pulls in the rest. Okay, so how would a typical web application look like? So again, that's our program CS here. We are basically configuring our services. So let's have a look how that looks like. So we're adding our controllers, we're adding our authentication, we're adding our cookie, and we're adding our OpenID Connect. Yeah, nothing's special here. We're using the code flow, and we are accessing or requesting access to an access token that can call our API, as we've seen before. Yeah, we of course disable mapping inbound claims, and also very important for being able to later on manage our access tokens is we're going to save the access token into the session. That's a built-in feature of the OpenID Connect handler, and what that does is basically it takes the artifacts that fell out of the initial authentication step, for example the access token and the refresh token, and then stores them in the session so that our library later on can reach into the session, look at the expiration and the access token, and then make a decision to get a new one and replace the old one with the existing one, and so on. So that's a required configuration if you want to do automatic token management. Okay, and that's a lot of magic going on here, but basically all that is required to enable the automatic access token management is this line of code. And that is coming from our library. And what this basically does is it plugs into the session management of ASP.NET Core. It plugs into the configuration system of ASP.NET Core, so that basically you don't have to configure your client manually, because if you have a look here, all of the client configuration is already done inside the OpenID Connect handler. So we set the authority, which gives us the token endpoint, right? We set the client ID, we set the client secret, we set the scopes, and everything is already there. So there's no need to configure explicitly our token client to do the token management in the background. So basically this line of code here plugs into all of this so that you basically have zero additional configuration. Okay? And then there's a controller, so you can exercise those flows from within your application. And again, you see very similar to the client credentials token management service, there is also a user token management service, which is doing all of the refresh handling. So you can use this directly if you want to. And I think there is, yes, there's an action here called call API as user manual, which is exactly exercising this flow. So basically you can see it calls into the token management service and says, hey, give me a token for the current user, right? Then creates a client with the client factory, sets the token, and calls the API. Okay? So if we would run this, so let's close this browser here, and if we would run that web, right, so here we are. So we can first of all log in, which triggers our OpenID Connect authentication workflow. So we're going to log in as Bob and Bob. Okay, so now we can call APIs as the currently logged on user, and this manual is exactly triggering what we just did, right? And you can see basically it is calling our API, and the API is echoing back the claims that it saw in the token. And again, you will get logging output here, and you see basically it says, okay, I'm going to get a token for this user, and this token is still valid, so that there's the user called Bob Smith, and that means we can call the APIs directly, right? If I talked for long enough, and probably going to call manual again, we should see now. Oh yeah, you see here, again, starting token acquisition. This time, since our access token is only 75 seconds valid, it says, hey, Bob Smith needs refreshing. So we are using that refresh token here to refresh the token at this endpoint here. And then as you can see, we are under the covers updating the session, and we are returning a refreshed token for the user, Bob Smith. And then we can call the API again. Okay, so again, the whole idea is that this library does all of the heavy lifting under the covers to do the refresh token and handling and replacing the existing access token with a new access token, and so on and so forth. Okay, so that's the idea of that. And again, there are various abstraction levels, if you like. So this one here was using our token management service directly. Now, the next level of abstraction is that we also have extension methods for HTTP context. So, and that is in a very similar style as the extension methods for the authentication system in ASP.NET Core. Instead of having to get those services from DI yourself, you basically just call hpcontext.getUser access token, and that again will return you a token, and then you can set the token on the manually created client. Okay, or again, one step further, as you can imagine, now we can do the same thing but using the HP client factory. So in this case, we have registered a client with the factory called user client, and you can see that client somewhere here. Let's go to program and configure services, like this. And you can see that here we have registered a client called user client, with the HP client factory, and same idea. You basically say, okay, there's a client called user client and you can configure it and so on. But whenever somebody uses that client now, this knows that it's under the covers connected to the token management. Okay? Again, the whole idea is that your business code should have minimal to zero protocol handling code. Okay? So anyways, this one here calls, give me the client called user client and just call it, right? And under the covers again, the whole token management will take place. And of course, you can do the same thing with a typed HTTP client. So you see in this case, I'm getting my typed HTTP client from DI and then just call a method on it. Okay, so same idea. And it's up to you really at which abstraction level you want to work. Manually using the HP extension methods or using the HP client factory abstraction. So that's really how you would use that library for most cases. There are tons of extensibility points here. For example, for client secret management, if you want to use something more advanced like X509 certificates or JSON Web Tokens, you can replace the whole user token storage mechanism. As I said, by default, it's using the ASP.NET Core session, for example, but you can replace it with something else if you want to. You can replace the caching and so on. Okay, and I hope this removes a lot of the boilerplate code that normally every single application has to do for OAuth tokens. Thanks.